Welcome to the deep dive. Today we're digging into some really fundamental ideas about knowledge, reality, mind, language, all through Bertrand Russell's eyes, specifically his 1927 book, Philosophy.
And this is a great one, actually prompted by source material one of you listeners sent in. It's classic Russell, trying to pinpoint the flaws he saw in just everyday thinking.
Flaws like being too sure of ourselves.
Yeah, that's one. He flagged three main defects:
Yeah.
being too cocksure, too vague, and often sort of self-contradictory in our beliefs.
Okay, so he's not aiming for some final perfect system then.
No, not at all. He explicitly compares philosophy to science. We should be piecemeal, provisional. We learn a bit, refine it, maybe get it wrong, try again. Not seeking some ultimate unchanging truth.
So the mission is more about cleaning up our own thinking.
Exactly, making it less cocksure, less vague, less contradictory. And he starts by challenging things we think are completely obvious.
Right. So where does he begin this process of challenging assumptions? He uses a really powerful example, doesn't he?
He does. He goes right for something incredibly basic. Our belief in everyday objects. Tables, chairs, the stuff around us.
Things we feel absolutely certain about. I mean, there's a table right here.
But how do you know it? The naive view is that you just see it exactly
Well,
as it is.
And Russell says that's impossible. Why?
Well, think about it. The way the table looks changes constantly, right? Depending on where you're standing, the lighting, even if you squint.
Ah, okay. So my view of it is different from your view and different from my view a second ago.
Precisely. So the table itself, if it's one single thing, can't be all those different, slightly contradictory appearances at once.
So that feeling of just directly seeing the table, that's got to be wrong.
It's too simple. Russell argues we're actually making an inference.
An inference from what to what?
From our private sensations, the patch of brown color I see, the shape in my visual field, the feeling of hardness if I touch it, we infer that there's a single, public physical object out there causing those sensations.
Okay, I think I follow. Sensations first, inference to object second.
And then, he points out, the physicist takes it another step. They infer things like electrons and protons from that inferred physical object.
But that chain of inferences from my fuzzy sensation to a solid table, then to invisible particles, you're saying Russell found that chain a bit shaky.
Well, he argues the logical steps aren't always clear. More importantly, the whole process relies on beliefs we hold unconsciously, assumptions we just make without thinking.
And philosophy's job is to expose those assumptions.
Exactly. To drag them out into the open and ask, okay, is this assumption actually justified? And often, Russell suggests, maybe it isn't, or at least it's not as certain as we feel.
Wow. So the very ground we stand on, metaphorically speaking, might be built on some unexamined leaps of faith.
That's the implication. It forces us to be more careful.
Okay, so if our belief in basic objects is an inference, what about the knowledge we use for science, like scientific laws? He talks about memory and testimony, right?
Yes, crucial sources. And guess what? They also rely heavily on inference.
How so? Memory seems pretty direct. I just remember.
But when you remember something, you have a present mental state, an image, a feeling. You infer that this present state accurately represents a past event. It's not the past event itself.
Okay. I see the inference there, and testimony learning from others. That seems even more indirect.
Definitely. Because first, you have the physical event. Someone makes noises, sounds in the air.
Right.
Then you have to infer that these aren't just random noises, like the wind. You infer they come from another mind.
A mind that means something by those noises.
Exactly. A mind that intends to convey information, not just, vocal cord vibrations. That's a huge inferential leap.
And Russell actually questions that leap. How can we be sure people aren't just making meaningless sounds? That sounds a bit extreme.
Well, he pushes it. The main reason we believe others mean something is because we mean something when we talk. But that's reasoning by analogy, applying our own case to others. It's still an inference.
Okay. And even within ourselves, it's not always clear what we believe?
Right. He asks, when you think something like mind is different from matter, are you grasping the deep logical content? Or are you just having a series of words or images pass through your mind? It's surprisingly hard to tell what's really going on internally sometimes.
So our own thoughts can be vague, and our knowledge from others relies on shaky inferences. And inference itself can go wrong.
Absolutely. Think about mistaking a reflection in a window for another room, or things that happen in dreams. Those are physiological inferences our brain makes automatically, but they can be mistaken.
And the fact that mistakes happen means we can't just trust every inference blindly.
We have to be selective, try to root out the unreliable ones to maintain consistency.
This relentless questioning seems to lead him towards a more objective way of looking at knowledge, the behaviorist perspective, like Dr. Watson.
Yes, he explores that angle thoroughly. Behaviorism tries to avoid the whole messy internal mind stuff because you can't directly observe it.
So they focus purely on observable actions.
Exactly. Knowledge, from this viewpoint, isn't an internal state. It's a particular way an organism reacts to its environment, something you can see and measure from the outside.
How does that work, like a chain reaction?
Sort of. Russell outlines the model. An external stimulus hits the body, causes an event in the nerves, then the brain, which then leads to a learned reaction, maybe words, maybe a movement.
So speaking English isn't an inner Englishness, but a set of learned physical responses.
That's the behaviorist explanation he examines. Your nervous system has been conditioned to produce these specific sounds and movements in response to certain stimuli.
And the underlying idea is that the human body fundamentally follows the laws of physics and chemistry.
Yes, that's his working hypothesis. It's just vastly more complex than, say, a rock or a pool of water.
What makes it so different then? This complexity allows for, what did he call them, vital movements.
Right. Movements that seem way out of proportion to the initial stimulus. He uses a great analogy. A tiny push can send a huge boulder crashing down a mountain if it's perfectly balanced.
Ah, releasing stored energy.
Exactly. The body stores chemical energy, and a small nerve impulse can trigger a release that results in a large, complex action. That's the physical basis for behavior.
Okay, so within this outside view, how do we learn these complex behaviors? He looks at Thorndike and Watson, right?
Yeah, he compares Thorndike's laws of learning. Things like repeating actions that lead to satisfaction, or just repeating actions often with Watson's simpler principle.
Which was?
The conditioned reflex. Watson tried to explain almost all learning through this mechanism, linking a new stimulus to an existing reflex.
And Russell notes a problem with Thorndike's satisfaction.
Well, from a strict behaviorist view, yes, satisfaction is subjective, internal. Watson wanted purely objective, observable terms. Stimulus-response conditioning.
Like the example of the child in the hot radiator.
Perfect example. Touch hot radiator, stimulus, pain withdrawal, unconditioned response. After just one time, seeing the radiator, conditioned stimulus, avoidance, conditioned response. No need to talk about feelings, just stimulus-response links.
But is all learning like that? Slow conditioning. What about those moments of sudden understanding? Kohler's chimps come in here.
Yes, this is a fascinating counterpoint. Kohler studied chimpanzees and found they could solve problems like getting a banana just out of reach in a way that didn't look like gradual trial and error.
How did they do it?
They'd seem to pause, survey the situation, maybe look at some boxes or sticks nearby, and then suddenly, almost in one go, stack the boxes or use the stick correctly. It suggested, well, insight.
Insight, like understanding the whole setup.
That's the impression it gives. A grasp of the spatial relationships leading to a complete solution, quite different from how, say, a rat learns a maze by gradually eliminating wrong turns.
So maybe there are different types of learning.
Russell suggests that. Perhaps gradual experience-based learning for many animals, but this insight capability seems more prominent in higher apes and humans, though studying insight objectively in humans is difficult, ethically.
Right. And even thinking, which behaviorists called implicit behavior.
Like talking to yourself silently.
Yeah. Russell points out it's hard for pure behaviorism to explain why that internal process is so effective. How does the structure of that silent talk actually help solve problems in the physical world?
It's a gap. There seems to be a connection between the form of thought and the structure of the world it deals with, which behaviorism struggles to fully capture.
Which brings us neatly to language itself. Russell sees this as uniquely human, right? Our key advantage.
Very much so. He calls it possibly our chief distinguishing habit. While animals signal, there's little evidence they build complex narratives or manipulate sentence structures like we do.
And he analyzes language in 3 ways.
Yes, words as physical events, the causes of us using words, and the effects of hearing words.
Physically, words are just mouth movements and sounds.
Pretty much. Movements of the larynx, mouth, tongue. And he notes they're physically quite vague. Distinguishing similar sounds like dog and dock depends heavily on context.
So how do we learn what these vague sounds mean? Back to conditioning.
Largely, yes, in the behaviorist model he's exploring. You hear the word bottle repeatedly around the time you see the bottle, experience feeding, excitement. The sound becomes associated with the whole experience through conditioned reflexes.
Okay, that's understanding. What about learning to speak, to use the words ourselves?
That starts, he suggests, with discovering that making noises is possible and sometimes profitable. A baby makes random sounds, maybe mama.
And gets a reaction.
Right, attention, food, whatever. So the baby learns that making that sound has desirable consequences. It becomes a learned habit, a skill developed through association and reinforcement.
So meaning comes from these associations,
Yeah.
causes and effects.
That's his working formula here. A word means an object, say cat. If hearing the word produces effects similar to seeing a cat, and uttering the word is caused by stimuli similar to those involved in seeing or thinking of a cat. It's all about these associative links.
And learning names for specific things versus general categories. Behaviorists see that as similar processes.
Broadly, yes. Learning Peter involves associating the sound with various appearances of Peter. Learning cat involves associating the sound with various appearances of different cats. The mechanism of association is seen as fundamental to both.
But sentences are more than just lists of words. Cats eat mice versus mice eat cats. The order matters hugely.
Absolutely. This shows we react not just to words, but to their structure, their relations. The ability to manipulate form is incredibly powerful.
But he also sees a philosophical trap here.
Yeah, because words for relations like eat or in or above look like words for things. Cat, mouse, table. Linguistically, they're just words.
Yeah.
This can trick us into thinking relations are things in the same way objects are, leading to philosophical confusion.
Fascinating. Language enables so much, but its own structure can mislead us. So let's loop back to perception now, viewing it objectively, behavioristically.
Right. From the outside, perception is seen as a specific type of reaction to the environment, mediated by the senses. It's a behavior.
And our senses are good, but instruments can be better.
In specific ways, yes. A thermometer is better at measuring temperature. But no instrument integrates multiple stimuli into a unified experience the way an organism does.
It involves that whole chain again, external thing, body surface, sense organ, nerves,
Brain.
reaction.
Exactly. That's the physical sequence.
And language helps make human perception seem less subjective than it is.
In a way, by using words like cat, we learn to produce a standard response to a range of similar stimuli. It makes our reactions more predictable and communicable, even if my private sensation of cat isn't identical to yours.
But here's a crucial twist Russell brings in. If we accept the physicist's picture of the world,
The world of atoms, energy, events, and space-time.
then my actual act of perceiving that cat, the conscious experience that's happening inside my head, right, as a brain event.
That's the consequence he draws out. If physics is true, then the immediate data of our experience, our percepts, are actually private subjective events occurring within our own physical boundaries, specifically our brains.
So the very starting point for our knowledge of the external physical world is itself internal and subjective.
Precisely. Infected with subjectivity, as he puts it. My percept of the cat isn't the cat out there. It's an event in me caused by the cat out there, via light, nerves, etc.
This explains that weird distinction between physical space and perceptual space.
Yes. Physically, my percept of my hand is an event inside my skull. But in my perceptual experience, my hand appears out there, definitely outside my head. Confusing these two spaces is a source of endless philosophical tangles.
And importantly, this direct awareness we have of our own percepts, or say, a toothache.
That's knowledge we get through self-observation.
And that knowledge isn't part of physics, is it?
No. Physics describes the world from the outside. But this introspective knowledge suggests there's more to reality than just the physicist's account. It supports the idea that thought or mind is real, challenging a purely behaviorist view that tries to eliminate it.
So even trying to be objective leads back to the subjective element. This sets the stage for the really big questions. What is the ultimate nature of reality? Mind, matter, both, neither.
Right. And here Russell engages directly with modern physics. He talks about the shift from older, more concrete models of the atom.
Like the mini solar system,
Yep.
Rutherford Bohr.
Yeah, to the much more abstract quantum theories of Heisenberg and Schrödinger.
Why the need for abstraction? Weren't the pictures helpful?
Helpful, maybe, but potentially misleading. Russell argues that concrete models inevitably state more than we can actually justify based purely on observation.
Can you give an analogy?
He uses a brilliant one. Imagine trying to understand Britain only by visiting its port cities. You could invent many theories about what the interior is like, all compatible with what you see at the ports.
Okay.
But the only things you can confidently assert are the very abstract features common to all possible interiors that fit the port data. Anything more specific is speculation. Physics, he argues, should be similarly prudent, sticking to the minimum structure inferable from experiments.
That makes sense. And then there's relativity. You said that had huge philosophical impact.
Absolutely massive. Its biggest contribution, Russell says, was ditching the idea of a single universal time and a single universal space.
Replacing it with space-time.
Yes, a unified four-dimensional continuum. This wasn't just tidying up. It fundamentally changed the geometry of the universe.
And gravity fits into this somehow. It's not a force pulling things.
According to general relativity, no. The fundamental physical reality between two events is their interval in spacetime, which all observers agree on. Mass and energy warp spacetime around them.
So objects just follow the curves.
Essentially, yes. They travel along the straightest possible paths, geodesics, in that curved spacetime. What we perceive as the force of gravity is just the effect of this curvature, like a marble rolling on a dented rubber sheet.
So physics gives us these incredibly powerful mathematical descriptions of the patterns of events in spacetime.
But it doesn't tell us why the patterns are like that. It describes the how, not the ultimate why.
And even when we look at the stars, we're not seeing solid objects directly.
No, we're seeing patterns of light arriving here now. We infer the existence and motion of distant stars and planets based on those patterns interpreted through physical laws, including the laws governing how space-time affects light.
Okay, so physics dissolves solid objects into patterns of events in space-time. Does this help with the mind-matter problem? What are we?
Russell thinks it does. He first attacks the old philosophical idea of substance.
Substance, like the underlying stuff that has properties.
Exactly. The idea that there's some permanent core, an it, that possesses qualities the apple is red, implying a persistent apple substance. He traces this idea partly to common sense things and partly to the subject-predicate structure of our grammar.
And science forces us to abandon this.
Modern science does, yes. There's no room for indestructible bits of matter or permanent souls in physics. An electron's continued existence isn't a static thing. It's a sequence of events, a tube through spacetime.
So applying that to ourselves, I think, doesn't prove a permanent I substance.
Not necessarily. It describes an occurrence or perhaps a series of occurrences, thoughts, feelings, perceptions, linked together by causal laws, especially memory. A mind or self is more like a structure, a pattern of events than a persistent thing.
This sounds like his neutral monism idea.
Yeah, it leads directly to it. The idea is that the fundamental stuff of the world isn't inherently mental or inherently physical.
Yeah.
It's neutral. Let's just call it events.
Events. How can an event be both mental and physical, or neither?
Well, take a percept, like your visual experience of seeing this room. From one angle, it's part of a physical, causal chain. Light, eye, nerve, brain event. So it belongs to physics.
Okay.
But from another angle, that percept has mental characteristics. It can be remembered. It can trigger associations. It's part of your conscious experience, what he calls mnemic effects, leading to cognition.
So the same event can be viewed as physical in one context and mental in another.
That's the core idea. Mentality isn't a different kind of stuff. It's about how events are organized and interconnected, particularly through memory and association. It might even be a matter of degree more complex organisms have more mentality.
So a mind is just a specific collection of these neutral events, unified by things like memory and perspective.
Pretty much. A bundle of events organized in a particular way. He also brings up the idea of emergent properties.
Like water being wet, even though hydrogen and oxygen aren't.
Exactly. Properties of the whole that couldn't be predicted just by looking at the parts in isolation. Perhaps mind or consciousness is an emergent property of a sufficiently complex organization of these neutral events.
Okay, wow. We've dissolved matter and mind into events. Given all this uncertainty and inference, how can we ever claim to know anything for sure? What about truth?
He tackles inference head-on. He distinguishes the traditional logical syllogism.
All men are mortal.
Right. Deductive inference. It's safe, logically certain, but often trivial because the conclusion is kind of already baked into the premises.
But that's not how we usually reason in life or science.
No. We rely on inferences that are much more important, but also much more precarious. The main one is induction.
Inferring the future from the past. The sun will rise tomorrow because it always has.
Exactly. Inferring general rules or future instances from observed past instances. And Russell connects this directly back to behaviorism.
How?
He argues that induction is essentially the principle of the conditioned reflex or association, elevated to a conscious level. We expect patterns to continue.
And he calls this animal faith. That's a bit dismissive, isn't it?
It's provocative for sure, But his point is that our fundamental trust that the future will resemble the past isn't based on logical proof. It's a deep-seated habit, an expectation built through experience, essential for survival, like an animal learning to expect food when a bell rings.
And our use of language, signs, relies on this faith.
Absolutely. When someone shouts, "Fire," you react as if you saw fire because you have this inductively formed belief connecting the word sign to the dangerous reality.
And belief itself, how does he define that behaviorally?
He links it to expectation and action. A belief causes an event or object or word to make you feel a sense of expectedness about something else, prompting you to act accordingly.
Okay, and what about truth and falsehood?
He separates formal truth, within logic, like 2 plus 2 go 4, from causal truth, which applies to empirical beliefs about the world. The causal theory says a belief or statement is true if it has the right kind of causal connection to the facts or experiences it's about. False beliefs lack this connection.
But the big philosophical problem of induction justifying that animal faith still remains.
Oh yes. How can we be sure induction works, or even assign probabilities? He mentions Keynes' attempts to put probability on a firmer logical footing in relation to induction, but it's notoriously difficult.
Yeah.
The core issue is that our most vital knowledge rests on a principle that seems more like a habit than a logical certainty.
So after tearing down so many certainties, Russell leaves us on the edge, looking at the limits of what we can know or even say. He ends with two big speculations.
He does, pushing right to the boundaries. The first revisits thinking and behaviorism.
The puzzle of why thinking works.
Exactly. Can behaviorism, just looking at stimulus response and maybe implicit speech, fully explain the remarkable success of abstract thought and verbal problem solving? Does its effectiveness imply some kind of deep correspondence, a resonance between the structure of our language and thought, syntax, and the actual structure of the physical world?
A connection between grammar and physics, almost.
That's the provocative question. Does thinking work because its structure somehow mirrors reality's structure?
And the second speculation goes even deeper, about language itself.
Yes, it asks.
Yeah.
Could the very structure of our language, which evolved primarily to deal with physical objects, actions, and relations in space and time, actually limit our ability to understand or even conceive of aspects of reality that might not be physical or might exist outside space-time?
So the tool we use to understand might also be sort of boxing us in.
Could it be? Are there potential realities or truths that our spatiotemporal object-oriented language simply isn't equipped to describe or grasp? It's a profound question about the limits of human cognition imposed by our primary tool, language.
Wow. Okay, that's quite a journey. From questioning a simple table to questioning the limits of language and thought itself.
It really is. And what stands out is Russell's method. That rigorous, step-by-step questioning of assumptions, the preference for careful provisional knowledge over grand, potentially unfounded systems.
Like science, building piece by piece.
Precisely. And he ties this capacity for knowledge, for analysis, directly to our power as a species and our future.
He has that sobering thought near the end, doesn't he, about where the real dangers lie now.
Yeah. He observes that historically the big threats were from nature. But going forward, the greatest dangers come from man himself. From how we choose to use the incredible knowledge and technological power we're accumulating, the challenge shifts from conquering nature to managing ourselves.
It really leaves you thinking. If our perception is partly subjective, our knowledge built on animal faith, and our language potentially limiting, how much confidence can we truly have about understanding the ultimate nature of things?
Or maybe the takeaway is different. What does it mean for progress, both philosophical and scientific, if it happens not through final revelations, but through this slow, careful process of finding flaws, clarifying meanings, and taking one small provisional step at a time? Is that uncertainty actually the most honest place to be?
Definitely a lot to chew on there. Thanks for walking us through this deep dive into Russell's philosophy.